Okay. So what we're going to do, recap a little bit. Last week, we talked about the mathematical standards and mathematical proficiencies. And if you remember, the goal of our mathematics instruction is to have mathematical proficiency. And you may go, well, what is that? And if you remember this visual from last week, it's this interwoven connection, this idea of we're looking at adaptive reasoning, strategic competence, conceptual understanding, productive disposition, and procedural fluency. And remembering back to last week too, and talking about what we see in classrooms, there's a huge focus on fluency, right? So that would be that procedural fluency. Do we know our math facts? Are we being drilled on that? And while that is a part of mathematics, that's not all of what we do as teachers. We need to really focus on conceptual understanding. Do they understand what's being asked of them? Do students see where it's situated in the real world? And then also problem solving, which incorporates lots of these different areas: adaptive reasoning, productive discussion, and strategic competence. So today we're going to talk about how do we move past fluency and look at what else is out there in terms of our mathematics instruction. So when we're looking at fluency versus conceptual knowledge, I'd like you to, for a minute, work on this problem on your whiteboard. So procedurally, I would maybe give you the problem, or a student in the classroom, please divide 2 by 1/4. What I'd like you to do is you can solve it any way that you want using an algorithm so you get the correct answer. But what I'd also like you to do is prove it. And the way that we do this, and this is what we're asking kids to do, and what Common Core really asks kids to do, is to draw a picture or use some kind of material to help explain their thinking. So if you would, I'm going to give you a minute or two to work on this, solve it, and then think about drawing a picture or some way to explain how you solved it. And then I'm going to invite people who are comfortable to go ahead and share. And I see some people are putting their answers up. You can put them down for now since people are still thinking. We'll give another minute or two. Thank you. I love that our class is so eager to jump in and share. That puts a big smile on my face, so thank you. Give me a thumbs up if you're at the point where you're ready to share something. You can do a virtual thumbs up. You can do a visual thumbs up. Some of you that have your cameras off, if you do a virtual, that lets me know since I can't see you. Thank you, Sydney, Gabby. See your thumbs. Perfect. Okay. All right. If you have a strategy, or if you're willing to share what you wrote on your whiteboards, will you please do the virtual hand raise so that I can call on you? Will, I see your hand up. Will you share your whiteboard with us and talk to us about?
Yeah, so I'm really lucky because we did this last week with my students in class. But I did the algorithm form, which is flip the fraction and switch to a multiplication. So 2 times 4 equals 8. And then I used a tape diagram to show. So you start with 2 boxes and write the 2 above, and then break each box up into quarters. And then you can just count straight across and see how many you counted out. And I got 8.
Awesome. Okay. I love that because so many of us, I'm seeing thumbs up. People are going, yeah, me too. So many of us solve it in this algorithm, right? Ours is not to question why, just invert and multiply. So we're taught to flip the fraction. We get an answer of 8, and it can be confusing for kids. 2 divided by 4 equals 8. That is a correct answer. But a lot of times when we talk about division, kids think, well, you're supposed to get a smaller answer. Why do we have a big answer like 8? What does that mean? How can I connect it to a context? So, well, having that picture there was really helpful. Sarah, do you want to add on or share what you have? I see your hands up too.
Yeah, let me lower it. So I did the algorithm as well, but then I don't know if that's right, but I figured, okay, that's 2 pieces divided into 4 gives you 8 total pieces.
Fantastic.
That's how I
love
did
that.
it.
Yeah. So you're taking the 2 wholes, you split them into 4 pieces, and then you count how many fourths are in 2 whole pieces. And that would
Yeah.
be 8. Absolutely. So you see how much sense the picture brings. The picture is bringing the idea behind the concepts. So the students have an ideology of like, what is this? What is fractions? What are we really doing? What's the action? Rather than just a procedure that's taught to them. Well, here's how you get the correct answer. That doesn't mean too much to us unless we understand the concepts behind it. That's really the power of mathematics. So it's well beyond fluency. We want them to have correct answers, but we really want there to be a focus on understanding what's going on. Jordan, I see your hands up.
I was just going to share in our class, we do a lot of ST math. And so it's not any procedural like writing your work, it's all pictures. And so I have the hardest time when they ask me for help because I'm like, I need to see like the steps. And so I'm trying to train my brain to like look at it and then figure it out that way. And I'm like having the hardest time doing that.
Yeah, especially since we're adults and we've been really like ingrained with procedural knowledge, or, well, I know how to solve this, but I need the numbers. So to kind of move away from that and go, let's go back to this idea of building conceptual development. And we know that Piaget talks a lot about this idea of moving from that conceptual understanding, concrete, to pictorial representation, and then representing things symbolically. So that would be the number. There's abstract thought that happens at all those levels, but those are entry points for students. So when we're planning lessons, we need to think about some students might solve this right away with an algorithm, and that's fine. But others might need to draw pictures. Others might still need tangible objects that they could manipulate. And that's what we talk about when we say, what are entry points so all students can be successful in a problem? All right. I see in the chat here, if you go to ST Math website, you can do a demo version. Awesome. So Jordan, if you go to the website itself, that can help you too with helping your students. If you're wondering what's ST Math, if some of you in your schools, the little penguin guy, GG, that's what it is. So a lot of times the students call it GG, but it's ST Math. So that's a supportive piece, a supplemental piece to mathematics that wouldn't be your major part of your instruction, but just to kind of touch on that since it came up. Awesome. Thank you for sharing, everyone. So hopefully you're getting the idea of moving past this idea of just fluency. So remember, last week in your online module, you really focused on the mathematical practices. Remember, there's 2 parts to the standards. One are like the topic domain areas that we teach, and then the other part is the how-to, and that's really the mathematical practices, and there's 8 of them, and they're used K through 12 education. So just to give you a reminder of those. So what are the things we make kids do in math class, and will they get us to where we need to go? Typically, this is what I see a lot when I walk into classrooms, and I know a number of you have talked about this as well, right? Lots of worksheets that are given to kids, and they're doing a page of problems. Maybe they're written a little bit in a different way, but they're all kind of that same problem loaded with a lot of different tasks. So we're looking at large quantity, not so much the focus on one problem, and really going deeply into that. So when we think how likely it is that worksheets will get us to our goal, so what are your thoughts about that? If I was teaching worksheets and just those procedures, how likely would it be that I'm going to get this idea of mathematical proficiency? And if you'd like to comment, you can just go ahead and raise your hand. Maybe hearing from someone I haven't heard from today.
Not very likely, because it doesn't accommodate to everyone and how they learn. But really, like alone, it doesn't really get us to any goal if you're just doing a worksheet on it.
Yeah, great. Thanks, Kenzie. So if we look at those worksheets, It definitely will help with fluency, which is one area, but look at what we're leaving out. So we really need to think about how do we have a more balanced approach to our mathematics instruction? Thank you for sharing. So we need a richer diet of math activities, and this includes things like beyond exercises, like our worksheets, like drills and practice. We need problems that require us to problem solve and use those mathematical practices, right? There's 8 of them. They really focus on rich discourse, on engaging with the math, and opening up the idea of having a task or a problem that maybe doesn't have just one right answer. There could be multiple solutions. So introducing that into the mathematics environment. I saw a hand go up and then I thought it went down. I don't want to rob anybody of an opportunity to add something. If that was you, go ahead and raise your hand again.
That was me. I just wanted to add about the worksheets. I feel like kids, especially when they're in class, they just are trying to like rush through it. So like not a lot is actually getting absorbed.
Yeah, thanks, Sydney. It's like a bunch of tasks, right? Like I have to get through all of this instead of really focusing on what's the problem asking. I've never been a fan of all of those problems because I figure if you can do 1 or 2, you could do a page of 50. So why am I spending all this time just doing multiple? So good point. Thanks for sharing that. Yeah, Kenzie wrote in the chat, it's also boring. Yeah, totally agree with that. And we talked about, we want kids to be engaged with math. How do we do that? Well, we have to bring our passion to the subject matter, but also we need to make it fun for them. And worksheets oftentimes are not very fun or engaging for them. So we're going to think about how can we move beyond that as well. Yeah, Sarah's going, yes, awesome, good. So let's look at what's an exercise versus a problem. So an exercise involves merely the application of a procedure. So that's what we see on those worksheets, right? That there's just, we're doing a procedure, we're getting to the right answer. So the solution path is clear. There's one way to get the answer. Here's the algorithm. Here's how we do it. Even when we see those worksheets, and at the very bottom, there's a word problem where everyone was like, oh, that word problem, that's the one that always stumped me. But really, that word problem was just another way to do all the problems you did above. So you didn't even really have to read it. If you were doing double-digit subtraction and all the other problems, that's really what you needed to do on the story problem. So you weren't looking at it outside of this context at all. So they're really just routine problems. So then when we think of exercise versus a problem is there's no procedure or algorithm. It's not obvious, right? We have to take a look at the context and go, what's reasonable here? The solution path isn't necessarily clear, and they're not routine problems. So there's not just numbers written on the board where you're computing an answer. You have to think about the context and where your answer would make sense. Let me give you an example of this. If you were going on a field trip and you had, let's say, 27 kids in your class, and let's say parents were going to drive them, you weren't getting a bus, and each parent could take 4 kids in a car, how many parent volunteers would we need? So that gives a context to the problem rather than just like an exact answer. So what I see some of you going and writing it down right now. So what did I say? 27 kids in a class. And if each adult could take 4 kids, how many adults would I need? Who would like to explain that to me? I see Sarah's hand up.
So I started out with the drawing the 4 per kit or per car. But then I did the division. So if you end up having a remainder, you can't just leave those kids at the curb. So
You
then
can't?
you would
You're not allowed to do that, huh?
depends on the kids. But then you would have to have 7 cars, but one of them would only have 3 instead of 4.
Yeah, I love that. Thank you. So you have to look at the context, right? A lot of times the answer to that problem, if I just set it up and said 27 divided by 4, the answer would not be 7. But given the context, you can't just leave a child. They need to all be included. So we need another driver. So wonderful example there. So not always is there one right answer. We always have to look how it's connected in a real world context. So did you notice that exercises can dress up in words? So what's a problem to me might be an exercise to you. Problem solving focuses on non-routine problems. So remember when I was talking about the worksheets at the end, there would be a problem given in a context. So that kind of looked like it was a problem, but really it was an exercise because it was just like everything else they had done, right, on a worksheet. So that's where we're saying exercises can dress up to look like problems, but they're really not. So I want you to be aware of that. So let's look at some non-routine problems, okay? What I'm going to do is I'm going to give you a sample problem to get us started. I don't want you to write anything down. I put hands in your pockets, please, or sit on them. You don't have to do that, but you don't have to write anything down. Don't solve this problem. But I want you to think in your head, how would you solve it? Okay, so this is just thinking time. This is just that mental math, like, what would I do to actually solve it? Okay. So it's the handshake problem. 10 people attend a party. Everyone shakes hands with all attendees. They shake hands exactly once. How many handshakes will there be by the end of the party? And clearly this party was like before COVID, so nobody's transferring any germs. So think about that. Is it a problem or an exercise in your mind, and why? How would you solve it? About what do you think the answer would be? So you don't have to have an exact answer, but what would be an estimate? So I'm going to give you a minute to think about that. So would anyone share, not necessarily their answer, but what you were thinking about? If you think this is a problem or an exercise, or maybe a strategy you were thinking that you would use if you were asked to solve this. And you can go ahead and raise your hand. Maybe if there's somebody I haven't heard from today, I'd love to hear from you. So not looking for an answer here, just do you think this is a problem or an exercise, and what you might do to solve it? I see people really thinking. Okay. How about this? Go into the chat and write if you think it's a problem or an exercise. And maybe tell me why. Great. I see Jenny put in the chat. She's a visual person, so she would draw it out to solve it. So you draw like the people and maybe the handshakes is what I'm assuming there, Jenny. Thank you. For that. Okay, some people put in that they would come up with like an algorithm or a formula for solving it. Some people said it could be an exercise because maybe there's one way to do it or drawing it out. But because you can think about it in different ways, someone wrote here that that also may mean that it's a problem. Okay. Somebody put both. Interesting. Yeah, I think it's a problem because you're building a formula to solve it. Good. Okay. So when we go back to the slide that we had, thank you everybody for contributing in the chat. When you saw that problem, it wasn't exactly obvious what the answer was or what you had to do. You had to think about it. There wasn't just one solution path, although you could do a formula. Somebody said I would draw it out. So because there were multiple ways they could engage in this problem, it would be situated a little more in this problem area rather than the idea of just an exercise. So hopefully that helps to clarify a little bit. Now here's what we're going to do. I'm going to have you really solve one. So it's similar to the last one, but 5 people attend a party. Everyone shakes hands with all attendees. How many handshakes will there be? So there is one answer for this. So a lot of times when we look at tasks, there might be multiple answers, but there is one answer for this. But think about how many ways you could solve it. So some of you talked about using an algorithm. Some of you talked about drawing a picture. So I'd actually like you to solve it, and then I'll invite somebody to share their work. As I'm watching you, I see some people are making eye contact with me, so they're kind of ready to come back. Others are still thinking and drawing. So I'm going to give another minute or two. If you've already solved it in one way, see if you can notate on your whiteboard another way to solve it, if you could solve it in more than one way. Would you go to your reactions, and if you're ready to share, if you have something that you could share with the rest of us, will you give us a thumbs up? I'm seeing a few thumbs, but also some people that still need some more think time. So I'm going to give you another minute or two to kind of finish up your thoughts there. Thank you. I'm seeing some more thumbs pop ups just for checking for readiness to share. Okay, well, one person go ahead and share what they came up with. If you'd like to share, just raise your hand. Jenny.
Oh, I don't think this is the easiest way to solve it, but I just kind of thought of how like a child maybe would solve it. So I wrote all 5 numbers, like the 5 people. You could draw the people, but I figured this is easier. So I did 1 through 5, and then I did little lines to each person representing the handshake. So 1 shook all of those 4 times, and then I went to 2, and 2 shook all those 3 times, and then so on. And then my answer was 10.
Okay, good. Thank you, Jenny. I actually think that makes a lot of sense, and absolutely what we'd see students do, right? Like they could draw out that actual shaking hands. Thank you for sharing. Will, I thought I saw your hand up as well. Would you mind sharing yours?
Okay, yeah. So I initially did Kenzie's algorithm, which she put up, which worked. And then I was thinking about a different way that it could be written, and I wrote it in like a programming speak because I used to do programming a little bit. So I came up with like a programming algorithm, which is just like n equals number of people minus 1, and while n does not equal 0, do n plus n minus 1. It's like a super complicated way to think about it, but you get the same answer. So.
I love that, Will, because we have kids that are definitely excited about programming and using computers and looking at that. So absolutely, that's something that's going to occur in the classroom. And right here, we showed 2 different ways to solve it, both very valid, both being able to share and contribute to class. And so we see the variance there as well. Kenzie, I see your hand up.
Yeah, so I was just going to explain my little formula that's up there. So I did the number of people times the number of people minus 1, because you don't count like your own handshake. And then you divide by 2 because there's going to be handshakes that don't want to be counted twice. Does that make sense?
Mm-hmm. I see, and I'm looking at Will because he's shaking his head because there's some similarities between the 2 of yours too, from a formula perspective there. So thank you. So now I'm thinking about learners that maybe some of this is like, I'm not ready for this. I'm not ready to look at the formulas. So maybe what Jenny shared would be helpful. But I also could take a group of students, right, and grab 5 people and have them do this, actually act it out, where they could shake each other's hands and we could count them. So that would be a real concrete modality for solving this problem. So when we think about setting up our math classrooms or engaging in problems, we want there to be a low floor, high ceiling. And what that means is there's entry points so everybody can engage in the math and be successful, but it's also pushing people that need more of a challenge. So how am I situating the learning so that all students can engage with the math? So that's kind of what we're looking at with this. Yeah, Will, is that are you looking at less translation model there? Is that what you put up?
Yeah, that's what I put up.
Well, I love that because that's actually where we're headed. So I feel like you helped me create this PowerPoint to some degree here. Here's some sample solutions. And many of you did things that were similar to this. So you could go to a formula. Jennifer did something kind of similar. This person used the bears, like the counters, but Jenny set up her handshakes for counting the movements. Here you have the people, you're drawing the lines. Maybe you use a T-chart. So here's 4 different ways you could solve that problem. So looking at it from multiple ways. And this actually goes to Les's translation model of representation. So the more representation you can create, the better you understand, and the better your kids understand, and the better you can teach and listen. So we want to use pictures. We want to use spoken symbols, manipulative aids, real world situations, and written symbols. So you may want to take a picture of this and it lands in your learning journals. You have this PowerPoint access to YouTube, but this is really important to think about. Am I incorporating all of these different ways in my lessons and when I'm doing problems? Because that's what's really helpful for students, looking at it in numerous ways. Good.
I was just gonna note, I didn't realize that I was unmuted, but I got the wrong answer. I put 20 handshakes, but after Jenny's explanation and I did it and Will's, I was like, had the mind flowing. Oh, okay. That's how you do it.
Yeah, and I love that because it wasn't like you turned in your paper and you got it right or wrong, right? You're able to see, oh, somebody else is helping me come to a solution. It's not that yours was far off. I'm also thinking how yours relates to Kenzie's because she came in and divided by 2. So if you at the end, so if you did, you would have gotten down to 10. So there is ways to relate to everybody's strategy that was shared. Thank you for sharing that, that your thinking process on that. That's helpful for all of us. I appreciate it. Okay, I'm going to have you do another problem and see what you come up with. A boy is twice as old as his dog. In 5 years, the boy will be 15. How old is the dog? See if you can solve it in more than one way, but at least come up with one way to solve this problem. Use those whiteboards again, because I'll have you share out. Stacy, I see your hand up.
You want me to share what I did or how I got it?
Oh, I would love for you to. Can I have you hold for 1 second there? I just want to make sure everybody's had a minute. Thank you, Stacy.
Yeah, I was gonna wait.
I love that. Thank you. Maybe thumbs up if you guys are ready to share, ready to come back if you've had enough time to work on this. If you do the virtual thumbs, that's helpful. Thank you. Jacqueline, I see yours. Alexandra, I see your thumb. Yep, Daisy, a lot of you. Sydney. Okay, great. Thank you. All right, Stacy, take it away. I'd love to hear from you.
Well, I didn't do like anything wild. I just, let's see. I think I need to make my screen mirrored. Hold on.
It looked fine from my perspective. I could see it correctly written.
Yeah.
I can't see it on mine correctly, but that's okay.
Yeah,
The
it's right.
screen mirroring is just how it looks to you. Everybody else will always see it the proper way.
Okay. So all I did, I just did 15 minus 5 equals 10 divided by 2. The dog is 5.
Okay, good. Can you
I don't know.
explain why you set it up that way?
I don't know. I just started with like, in 5 years he'll be 15. I took away 5. That makes the boy 10 divided by 2 because you said he's twice as old as the dog, and then 10 divided by 2 equals 5.
Perfect, Stacy. Absolutely.
I
There
could
you
have done it
provided.
more. I guess I could have made a graph or something like that, but that's just
I love that. I think that's very reasonable, and you were able to articulate your thinking and show it numerically as well. So thank you for sharing.
Thank you.
Do we have someone else who would like to share that maybe solved it a different way? It's more typical for us to go right to the numerics because we've been so indoctrinated with going right to the formula and getting the correct answer. So for us to take a step back and go, how would I use words? How would I use pictures? Can be challenging. So we're going to work together on doing some problems in a little bit so you don't feel so alone. Like, how do I come up with this? We're going to problem solve together. But Will, I saw your hand up, if you don't mind sharing.
So I have 2 ways. I have the formula way over here, and then I also over here, and then I also drew a picture where I just drew the boy and his dog, and then the boy and his dog 5 years later. And I said that if in 5 years he's 15, then back here he must be 10. And so the dog is going to be half that age, so the dog is 5. And then just like the formula way of doing that same picture.
Good. Awesome. Thank you. Did anyone else want to share what they came up with? So basically, we know we can use multiple ways, right? Formulas, words, pictures, maybe a number line. How could you use an area model? How else? So I'm going to show you a sample journal spread here. For a boy is twice as old as his dog. In 5 years, the boy will be 15. How old is the dog? So you can look at different ways, different models. And again, you have this PowerPoint, so it might be something you want to take a look at when we're trying to look at other ways to solve problems rather than just going to the formula, although the formula is completely fine. We just want to make sure we're looking at multiple ways to solve. Yeah, I see. I did what Will did. Okay, Kenzie was saying she did the same thing there too. Good, thanks. Trying to monitor the chat in between as well. All right. So what we're going to do is really look at now rich tasks, right? We've talked about exercises, which are like those page of worksheets. And then we've looked at problems, which you had to engage with and think about how to solve them in different ways, even though they were still arriving at the same answer. And then there's something called rich tasks. So what we make kids do kind of falls on a continuum. We start with an exercise, a simple problem. Many times we take away the context. We just show them how to do a procedure, or, well, you just do this to get to the right answer. So do that on the rest of this page too, and take it home for homework and come back and we'll take a look at that. So it's a recipe. It's an algorithm for how you solve it. So that's what we see many times happening in classes. And then sometimes we move into story problems. So that's the word problem that's on the bottom of those worksheets. So they kind of dress up an exercise and make it a story problem. And then we move into